Good morning and warm greetings from Rohini College of Engineering and Technology. I am G. Tangam, Assistant Professor, Department of Physics from Rohini College of Engineering and Technology. In this video lecture, I am going to discuss about the solar cell course outcome. After successful completion of this course, the students will be able to explain the working and construction of solar cell. What do you mean by solar cell? So it's a familiar topic. So solar cell is also made up of PN junction diode. So it's this PN junction diode will convert solar energy into light energy. So normally the light energy, that is the light energy from the sun, is falling on the solar surface. When this light energy is falling on the solar surface, it will be converted into electrical energy for producing current or something. So it is a PN junction diode which converts the solar energy into electrical energy is called solar cell. So that's about the construction of the solar cell that is shown in this diagram. So we can see about the construction. So this solar cell consists of PN junction diode. Already we discussed about that. So PN junction diode is made up of silicon, and now this PN junction diode is packed in a can. So it is kept in a box with the glass window on top of the can. So due to that, the light can be falling on the top of the glass top and it can send into the P and N type material. So normally the thickness of P region is kept very small because the electrons generated in P region. So normally the electrons will be generated in P region because when the light is falling on the surface of the solar cell and it is moving towards the P region, in this we have electrons and holes. So normally the electrons will be produced in the P region and these electrons may be diffused to the junction before recombination takes place. So the thickness of N region is also kept very small to allow the holes generated or holes which are created in the N region and they may diffuse to the junction before they recombine. So in both the cases the P and N regions are kept very small thickness. Why? Because the electrons created in the P region, that is the opposite one, and the holes created in the N region should diffuse into the junction before recombination. Otherwise if they see one each other, they will recombine with each other. So to avoid that one, we have to keep the thicknesses very small. So above this P and N region, we have a nickel ring. So nickel ring is provided around the B region, which will be acting as a positive output terminal. And we have a metal contact just below the N type region, which will be acting as a negative terminal of the battery. So working. So first, when the light radiation is falling on the junction from the sun, now due to the falling of this light radiation, there will be a production of electron hole pair by carrier generation process. When electron hole pairs are generated in both the P and N side of the junction, so majority carrier electrons in the P side across the barrier potential to reach N side, and the holes in N side will move towards the B side. Due to the movement of positive charge and the negative charge, there will be a production of minority carrier current. So the electrons and holes are accumulated on two sides of the junction. Due to this, there will be an open circuit voltage which is a function of illumination. So illumination means depends upon the intensity of illumination, there will be a production of positive and negative charges. So that's all about this solar cell for the conversion of light energy into electrical energy. Thank you.